evaluate each of the following, and then we're given 6 cube roots to evaluate. We'll do these one at a time, starting with the cube root of 8. Now, when we're looking for the cube root of a number, we're asked to find the number that we could cube to get the radicand. Remember, the radicand is the number on the inside. The symbol is called a radical symbol. And also, the little number up here is called the index, and that tells us which root we're taking. So here we're taking the cube root. And so we need to ask ourselves, what number can we cube or multiply by itself 3 times to end up with 8? And the answer ends up being 2, and this is because 2 cubed is 2 times 2 times 2, which is 8. So in this case, the answer is 2. The cube root of 8 is 2. Instead of asking what numbers we need to square to get the radicand, here we're asking what number we need to cube to get the radicand. Let's look at some others. Let's look at the cube root of 64. We need to know what number we can multiply by itself 3 times, something times something times something, to get 64. And it's not 2. We know 2 cubed is 8, so we need something bigger. It can't be 3 because an odd number times an odd number times an odd number won't give us an even number. So we could try 4. 4 times 4 is 16, and if we multiply 16 times 4, we do get 64. So it seems as though the answer is 4. This is because 4 cubed, which is 4 times 4 times 4, is 64. Again, I'm not going to write out this reasoning every time. I just want to do it the first couple of times so that if anybody hasn't seen a cube root before, they're understanding where these numbers are coming from. Let's look at the next example. We have the opposite of the cube root of 27. So here, we're going to leave that negative sign on the outside alone just for a minute, and we're going to look at finding the cube root of 27. So we need to know what we can multiply by itself 3 times, something times something times something, to get 27. And 27 is between 8 and 64, so the answer is going to be between 2 and 4. It's going to be 3, and this is because 3 times 3 times 3 gives us 27. However, this negative out front means that we're going to have a negative out here, and so the answer is going to be -3. Now, in the next one, we have the cube root of -125. Now, when we had square roots, we weren't allowed to take the square root of a negative number because you can't square something and end up with a negative. At least you can't square a real number and end up with a negative. But here, we can cube a number and end up with a negative. In fact, we can cube -5. So the answer is going to be -5 because, and I will write this one in, I think this is a good one to see. If we take -5 cubed, that's going to be -5 times -5 times -5. And when we multiply the first two, a negative times a negative is a positive 25. And then when we multiply that by -5, the final answer is -125. And I'm also going to write in the answer to the last one, or the reasoning, because if we take the opposite of 3 cubed, that negative sign stays at front, and we've got 3 times 3 times 3, and that gives us -27. When the negative is on the outside of the radical, there's no parentheses in the corresponding exponential expression, and so it expands like this. But when the negative is inside the radical, that means that we have the negative inside parentheses if we're writing out an exponential expression that matches. So I'm just writing these out so that you can see the corresponding exponential expressions that match the radical expressions over here. All right, let's move on. Let's look at the cube root of 4096, which is a very large number. So This is definitely going to be bigger than 5 because 5 cubed gives us 125. So let's try something bigger. Let's try 10. Well, 10 cubed is 10 times 10 times 10, which is 1,000. So 10 isn't big enough because we need it to be 4,000. We could look at 20. 20 cubed is 20 times 20 times 20. If you do that out, you end up getting 8,000. And we're looking for something that we can cube to end up with 4,096, which is in between these. So we actually need something in between 10 and 20. Let's give 15 a try. 15 is between 10 and 20. Now, if we take 15 times 15 times 15, we end up with 3,375, which is still too small, but we're getting closer, so let's try a little bit bigger. Let's go with 16. And if we take 16 times 16 times 16, we do get 4,096, which means the cube root of 4,096 is 16. Now we have one more. We've got a fractional one. We've got the cube root of 1/256. And just like a square root of a fraction, when we have the cube root of a fraction, we can take the cube root of the numerator and the denominator separately. The cube root of 1 is 1. Cube root of 256, well, 256 is less than 1,000, so it's going to have to be less than 10. If we go with 8, 8 times 8 times 8 does end up equaling 256. So we've got an 8 in the bottom. And then we can see that the cube root of 1/256 is 1/8.